Servus and welcome to this very first video where I do a live programming of a dedicated topic. We will see a complex scenario of garden watering and how I break it down and program it step by step. With over 5 years of experience with the config on a daily basis, I guess that you will learn the one or the other trick from me. So let's go. So I did a little visualization for what I'm planning to do now. We have two circuits to be watered, the front yard over here and the backyard. And we have, for both circuits, they can be turned on independently. So you can only water the backyard if this is the only one who requires water. And for this, I use magnetic valves. They are available in 24 volt DC, and there's basically two different versions. Normally open and normally closed ones. So depending on the NO or NC, it is letting water through or not without power. And in our case, we assume that when we power them with 24 volt, then it's open and water goes through, and else it is closed. Okay? So this is here. Then we have two sensors to really measure the humidity of the ground. If the grass or if the ground, the earth is wet or not. And they deliver a 0 to 10 volt signal, which we will transform into a 0 to 100% humidity value. Okay? And we would like to say if the ground here is below 20% humidity, we would like to start watering until we reach 40%. The reason for that I will explain you later. And that's this part. Then we have here a rainwater tank with a sensor to see how much water is in there, and a pump. And of course, if you want to use the rainwater, the pump needs to run. Then you have two more valves to switch between, hey, is it paid water or is it rainwater? Okay. In addition, we would like to say if it rains tomorrow, so we use a weather forecast, then for a certain amount, let's say 5 liters per square meter, or I don't know what makes sense for your specific project, then we will not water today. On top of this, we have to say, hey, during the day when the sun is shining, we are not allowed to water it because the bubbles of the water, the raindrops, it will burn the grass otherwise because it's like a lens, the water drop. Okay, so with all these conditions, we will now program live. So let's jump into the config. Okay, so I'm starting with a blank, almost blank config file. The only thing I did already is I labeled all the different outputs. So you see valve paid water, rainwater, backyard, front yard, the pump, and so on. Also the analog inputs, the sensors, and you see here it's a 0 to 10 volt sensor, and I say it goes from 0 to 100% humidity. For the rainwater tank, we also just assume for more simpleness that 0 volt means empty and 100 volt and 10 volt means 100% full. In reality, you would really need to measure with the sensor in the live view, and then you would see, okay, if it's empty, I get 2.34 volt, and if it's full, I maybe get 4.31, and then you could validate the sensor like this. But for our case, we just say 0 to 10 means 100, 0 to 100% full. Now, how should we start now with this maybe complex scenario? And I always break it down by the relays. So I always start with just adding the relays onto the page. And maybe let's start with the rain and paid water. When should happen what, or when would we like to use which of them? And we said with the rainwater tank, if it is containing water, then we would like to use the rain, and otherwise we would like to use the paid water. Okay, so how could we do this? I would say, if there is at least 5% rainwater inside, then we use it, else we use the paid water. Okay, just to be on the safe side, 5% full. Now we could use as simple as a comparison where we say if it is greater, So if the 0 to 100% value is greater than 5%, then we use the rainwater, and that's it for the rainwater. How do we now do the same for the paid water? We could say if the rainwater tank is less than 5%, then we use the paid water. Or, maybe a little bit more elegant, is I could also say if it's not the rainwater that we use, then it's automatically the paid water. Okay, so this is also an option. So I say here, if it's not greater than 5%, then it's the paid water. And what about the pump now? The pump for the rainwater here. Because if we want to use rainwater, there is no pressure inside. So we need to have a pump which then delivers us the pressure if required. So we can now simply put the pump for the rainwater also on the same grader here. And then once we can simulate as well, once it is greater than 5, so you see now it's 0, then it's off and the paid water is used. And once it's greater than 5, let's say 10, then you see both the pump and the valve for the rainwater will both be active. There is maybe a little expert programming that you can do, and this can, if you think about, the valve here needs, let's say, 5 seconds to fully open. So I would make a little delay between the pump and the rainwater so that the pump does not already pump, really hard pumping, against the closed valve, and it takes them a few seconds to open. So this is also very easy to realize. We simply disconnect the pump here. We say with F5, you can search, by the way. We put a monoflop inside, which transforms, sorry, not a monoflop. We put a switch on delay in between. And this, as the name suggests, has a little delay between switching on that you can define here in its properties. So we say 5 seconds, and then also the pump turns on to give enough time for the valve, the rainwater valve, to open. Again, if we test it here, we say now it's off. Now, so it's paid water. Now if the value increases to 7, let's say, it's raining, then you see directly on, and after 5 seconds, now this is also on. Okay, so we already did the first part of the example, this one here. It's already done. Now, how can we say Q3 and Q4 front and backyard? What's the condition here? So I break it down to very small steps here. And therefore, I have my 2 valves here, front and backyard, and I have my 2 sensors for the humidity here. And a very simple way of doing it would be, again, I use the less function block, less or equal, and then I say if the humidity of the backyard is, let's say, less or equal than 40%, then I water it. Sounds great. But if you think about what happens if the humidity is very close to 40% and you water it and then it's on 41% and then it dries up a little, it's 40 again. So this could lead to the fact that it's watering and stopping watering very often. You would do the same for a boiler. When you heat it up to 60 degrees, you would not make it with a less, because then it would be like, okay, heating up, 60 degrees, stop. And then it goes back to 59.9. I have to turn it on again. So it would be like on, off, on, off, on, off. Therefore, we could rather use a 2-position controller, which I will show you now. Okay. And when we, because it's more clear maybe, when we think about the boiler and we say here the target value of the boiler should be 60 degrees, then we can put a little hysteresis in here. So if we say the hysteresis is 3, then we would say if we heat up, just think about the boiler now, simulation, we are at 0 degree, so a freezing frost boiler, no, then we heat up, 57, still heating up, then we are at 60, but still heating up with the electrical heater, and then 63, it's off because the hysteresis was 3. Now we can drop again, 61, still on, still off, 60, still off, 58, still off, but at 57, because it's 3, the hysteresis, we turn on again. So you get a longer duration from switching on and off. So it goes from 57 up to 63 and then drops again to 57. Okay, so you don't turn on and off that frequently. So a little excurse, but for our garden watering, we could say we want to reach the target value 30 and the hysteresis could be 10. What this means is that now the ground is completely dry. We water it here with the valve. You see it would be on until we reach 30, still on. So we go up to 40 and then we turn off the watering. And then we drop again, 30, it's still off. So we wait until it's 20 to turn it on again. Maybe this is too much. Maybe hysteresis of 5 would be better. Then you would go from 25 to 35. Whatever makes sense for the plants you have. And just depends where you live. Okay. So now it would look like this. The valve for the backyard turns on when my 2-position controller with the humidity measured here is between 20 and 40. The watering will be active. We can also copy and paste the function block, which then also copies the properties here. So if I add a new 2-position controller here, then I would need to put the new or the values, if they are the same, in this case they are, I would put them in again. So Control C, Control V to copy and paste. And now this part here is already done as well. The next point was that we do not want to have this all happening if rain comes within the next 24 hours. So there is different options here. You can use the weather service, you can use the precipitation value here, where you can set, you can say the current one or with an offset or at a certain time. But since the recent version, there is also a system variable, which is pretty cool, where you can say the expected precipitation for the next hours you define here, up to 66. So let's say we keep the 24. You could also say within the next 12 hours or whatever. But here we say the next 24, and the unit here is liters per square meter. So I put this on the page here. And now we say, okay, when do we want to water? If it's less than 4 liters per square meter within the next 24 hours. Again, completely dependent on what your plans are and your project is about. Okay, so these values can be individual. So if the expected rain is less than 4 liters per square meter, then we would like to block the watering here. And how can I do this? In my case, I like to make a memory flag here. And the memory flag, you can place them on the page. And here I say it's called watering allowed. For me, it's a clear name. And I connect it here. And now this memory flag can be used wherever and how often I want on any page. So also if you have another page here where you would like to transfer this value, I also like to use memory flags for this. Okay. Oops. Delete this one. Delete page. There we go. So I have my watering allowed here. And first of all, let's block here the rain and paid water, because again, if there is rain forecasted, then I do not want to switch between the valves because I don't want watering at all. So how can I do this? And maybe an easy way could be to say here, if the water tank is full, right, and watering is allowed, then I want my stuff to happen. So I can disconnect this here. I say these conditions here, water tank is greater than 5, and watering is allowed because the precipitation, the expected one, is less than 4 liters per square meter. Then I say, okay, if this both is true with an AND connection here, then I turn on my pump with a delay of 5 seconds and I turn my rainwater valve on, and I have my knot with the paid water here. So I can test this now. And let's say the rainwater here is full, is empty, and then you see, oops, the paid water is still on. So I need to make the logic a little differently, and I figured this out with a simulation. So I often use this. Also, by the way, with F7, you can start and stop the simulation with a shortcut. So let's test this out. Let's go to 14. So this here is on, and the watering here is allowed, then it works. What is if the expected precipitation, it's a hard word, is 15 liters? Then you see it's no longer AND connected, and here the rainwater valve is not turning on, but still this is turning on. So we have to do this AND connection logic with a memory flag. Also, you can copy and paste. If you select multiple function blocks, you can copy and paste the whole logic. So I have to make it like this, and not, oops, like this. And now let's test it again. F7 starts it. Watering is not allowed because we have, again, more than X liters per square meter. And then you see here, it's now blocking the paid water valve as well. Okay, you see we can test it. We can also go to rainwater tank has some water, and still the pump for the rainwater and the valve do not turn on. But if I now have no expected precipitation, let's say 1 liter only, then I see here, okay, now it's again allowed here to have the rainwater, and once the tank goes empty, let's say we have only 1%, then we switch back to the paid water. Okay, so already a little bit more complex logic, but you see, I often use the simulation to just double check, even if it's a simple logic, because like this could likely be forgotten, that this knot will still here lock my stuff. Okay. An additional option would have been that I put this AND watering allowed directly in front of the valve here. But then I need to do this in front of this, in front of this, and in front of that. So maybe or maybe not, this was a little faster because I just needed to make it one time here and another time here instead of 3 times. But just so you know. So now let's clean up a little our page. So we can delete this one memory flag we have added here. Then we put this up a little here, this as well here, and this one here as well. The next thing I would like to do is to say if there is frost coming. So if it's freezing, then I have to stop watering at all because it could damage my pipes. How can I do this? By the way, if you ever find yourself, hey, there is just not like the usual things here in my periphery tree. This can be because of the automatic filter. And this one filters for the page that you currently are in. So if you would like to find all the related, let's say, lamps for a dedicated room, you have a kitchen, living room, bedroom, and then you go into this room bedroom, and then you filter automatically. You only see the touches, presence sensors, and so on for this dedicated room. And here you can deselect it. Now, frost protection. Again, we can use here a variable, a system variable called outdoor temperature, and you can also choose the source for it. So if you have a weather station locally, Loxone weather station, you can choose here also the real locally measured sensor for the outdoor temperature. You can also define this value by logic. So if you have a third-party 0 to 10 volt outdoor sensor, then you can define it by logic, connect your 0 to 10 volt sensor to it, and then the outdoor temperature variable is set as well. In our case, we use, as we have it anyhow, the weather service. Okay, we put it on the page. I always scroll out a little to position it where I want it, and then I can zoom in while holding control and then mouse wheel up and down. Okay. Then let's say, when should we stop watering? When the temperature is below a certain value. So we could again say less than something, 5 degrees, for example. Again, we could have the same topic if the temperature is 4.5, 5, 4.9, 5.1. Again, it could be locking and starting and stopping the watering again all the time. So there is another function block I'd like to show you, which is the threshold switch. You see it here. What this has is it has an on value and an off value. So it's a little similar than the two-position controller, and I will show you here. Let's say we want to have the frost protection active below 5 degrees, and then we go up again till 10 degrees until we turn it off again. So if we simulate it, or with F7 for the pros, then you see at 0 degrees it's on, and then it needs to heat up outside, because you see 5 degrees, it's still on, the frost protection. 7 degrees still on, 10 degrees it's off, and then until we drop 7 degrees still off to 5 degrees again, then it's on again, the frost protection. Okay, so for the frost protection we could now use another memory flag, or we can also use an operating mode called frost protection. Depends on the project. Maybe you use the frost protection for something differently, then you could make an operating mode out of it. But in our case, we use a memory flag, which we call frost protection. Okay, and we connect it to it. And when the frost protection is active, watering should be not allowed. So how can we easily do this? We can now put the frost protection on the page, and we could say here again, with this and stuff, we could lock it here in addition, and not frost protection, and not frost protection. Or we could say, as we use here the watering allowed anyhow already, we could say we put the frost protection into relationship here already. So if the precipitation is less than 4 liters, watering is allowed, but we also say and, so it is allowed, precipitation, and there is not the frost protection active. And then we can already use the logic for the valves that we have already programmed, because it's up here already, and watering allowed. And the watering allowed now has this additional condition from the frost protection. Pretty cool. Okay, we already managed to do a lot. But the next thing is that we want to limit the automatic watering for the times without sunshine. So in the early morning or after sundown. And there is a few ways we can do this. First of all, the easiest one would be to use a schedule function block. And here we call it watering allowed or watering times. And then we can, with a double click on the rubber here, delete everything. And then we can say in the morning from 6 to, I don't know, 8 every day. Like this. With control, you can copy the entry. And also, let's say after 6 till 8, another 2 hours, it's allowed to water as well. Okay, you can then, of course, as the end user, change these times in the app. And then here, how can we now use this to lock the watering or only allow it in these times? The output, AQ, here, is active once the times are active. How can I simulate this? Should I now wait until 6 or should I make a fake entry just to test? No, there is a cool feature in the simulation that you can use the current times. You see actually it's 4 p.m. now. Or you can say I want to use a dedicated time, and now we say it's 6, almost 7. Okay, and then you see here the output AQ is on. If I use the current time, you see the output is off due to my schedules that I made here. Okay, and now I could again just use this one and put it in front of my watering allowed memory flag. So I could make another and afterwards here. So like this rain forecast is less than 4 liters and there is no frost protection and watering from the schedule is allowed. So I could make it like this. Or what you can, or what you might not know is that the inputs of the and can be used multiple times. And these inputs are and connected. So it is exactly the same as if I would do this here. Okay? For an OR block, like this, the inputs are OR connected. So you could connect 10 digital inputs on one OR block and whatever, or let me just show you. Let me use the digital inputs that we have here. Here. And let's do it like this. 3 and 3. And now go to the simulation. And then you see if this is on, it's on. If multiple ones are on, it's still on. If just this one is on, it's on. And for the AND, it's the same. So if I use multiple ones on the input, it's AND connected. That's the only difference. So it means this input here and this input and this input, then it's on. Okay? But again, if you would like to be more visual, then you can do it like this and it's exactly the same. Okay? Just a tip. This would be one option. The not the problem, but the downside is that this has fixed schedules. So let's say maybe in summer, in June or July, it might be sunny until 9. And in winter time, I mean, you don't water there anyhow, but you know what I mean. So you could make this variable as well. Therefore, you can use here in the time section some things like the pulse at sunrise, the pulse at sunset. And you can make a logic that after sunset, you can allow the watering. But for the sunrise, it's a bit more difficult because here at the pulse for the sunrise, you already know, it's already sunrise. So you would need something like before the sunrise. You know what I mean? So there is a way to do it. It's a little bit more complicated, but for the basic version, let's say we use the schedule block, which the customer can also change in the app. And now we do the very, very advanced version. Okay. So there is a time for sunrise. Here, time for sunrise. And then there is minutes past midnight. And now you see where this is going. If I simulate it now, you see the time of the sunrise is 375 minutes after midnight. So what time would this be? If I divide it by 60, so which is 375 divided by 60, it's like 6:05. Okay, no. So it's 6:15 in the morning, the sun goes up. Today in end of August. So this is changing during the year. And now this is my time past midnight. So if I again divide this 966 by 60, you see it's 4 p.m. as you see here, and 0.1 means 6 minutes, right? So 0.1, 10% of 1 hour is 6 minutes, okay? So we work with these minutes here. And how can we now say, let's say we want to water 2 hours before the sunrise. So 2 hours means 120 minutes. So we say, now it's getting serious, subtract. We subtract from the minutes past midnight, we subtract 120 minutes, right? No, the other way around, from the time of the sunrise. So we want to be 2 hours ahead of the sunrise. Again, simulation, F7. So you see 375 minutes minus 120, so we're at 255. And now we say, if this value here is lower, now wait, let me think. If this here now is equal to this, we could start a 2-hour pulse, monoflop. This can we do. I had to think myself now with all the minutes and subtraction. So if my current time is equal to the 2 hours before the sunrise, that's what we did here, then I make a monoflop. And the monoflop gives me a pulse of 120 minutes. But here it is in seconds. Here in the brackets, you see it's in seconds. So again, we can say, okay, what is 2 hours? 2 hours times 60 is 120 minutes, times 60 is 7,200 seconds. Okay, and for this time, the watering now should be allowed. This is the morning. And now we could do the exact same thing for the sunrise, the sunset. And if the sunset comes, again, then we can do 2 hours after sunset. So we copy the monoflop with the 7,200 seconds, like this. And we can say or. So either in the morning for the 2 hours or in the evening after sunset for the 2 hours. Here we say it is allowed. So we can then connect it to this end here. And of course, either you use this variable logic or you use this schedule here. Okay. So in our case, let's go for the variable logic. Okay. So now we say here only before sunset, after sunset and before sunrise, 2 hours before each, and after sunset in the evening. Okay. Wow. What else can we do? What if you want to have the option as a customer to disable the garden watering? Let's say you have a party at the evening in the garden and you do not want the watering to happen. Then I would make a switch, which I call party mode. or you can call it watering blocked if you would like to be more precise here. But let's say party mode, because this can do more things then, like turn on the light outside and whatever. And if the party mode is active, then I do not want here this to be allowed, watering allowed. So again, I can make another, and I can also connect this here as well. So all of this, and not the party mode. So I could add a not button in between here as well, like we did here. But there is one other way to negate, invert the input, and this is when you ever moved your mouse over an input, you see there becomes this little dot, and if you click on it, it becomes red and has this circle here. And now it's exactly the same as if I would put a not function block in here. Okay, and now I can switch the party mode on, and now all the watering is no longer allowed, because here, and not the party mode. Okay, and this can be shown in the app. I can actually just show you real quick. I need to reconnect to my demo case, and first I need to connect to the Wi-Fi. Okay, Wi-Fi connection there, refresh. Just a sec, here it is. Okay, and if I save this now into my file, mini server is restarting, and if I open my visualization now, here, web interface, local address, I see that in my room garden outside there is the party mode, and if I activate it, then I see in the live view here, I see this is on. So whatever happens here before, it can never be on here as long as the party mode is active. Okay, so the live view is also another tool which you can use. Either you press something real, you check something, or you check if you, like here in the app, you do it. So this is live. So this is not a simulation, but that's the live view. And the name tells you what's going on live on the system. So this is also something cool. I could stop here now, but let's add just for fun a little more things. Let's say here we would like to have an automatic emptying of the pipes. I hope not, this was a bad English, but we want to automatically empty the water in the pipes when the frost mode comes on. So let's say, I mean, if this makes sense or not, let's say we put a compressor in here before the Q3 and Q4, and the compressor, if we turn it on, it blows out the air, it blows in air and the water comes out. So even if it freezes, it cannot damage the pipe. Okay, let's not say this is reasonable, but let's say this is possible. So we have another actuator, the compressor frost protection. And if we turn this guy on, so actually it's here, the compressor. So if we turn it on here to blow out the water here and here, then we need to open the two valves, of course. So when do we need the compressor to turn on? When the frost protection comes on. Okay, then we stop the watering and we want to blow out the air. So again here, frost protection is on, and also we turn on the compressor. Now we need to open also the valves, right? So we could say now, if the frost protection is on, which is a memory flag, it's the same value always as the compressor, then by whatever else logic happens before the valves, it doesn't matter if we directly here connect the frost protection memory flag onto the valves. So even if the garden watering, party mode, whatever is on, which blocks the watering normally, if we put the memory flag right before the relay, it it doesn't make a difference. Whatever is before here doesn't make a difference. If this is on, it's on here, it's open. But that's fine, because during frost protection, the other two valves, paid water and rainwater, are both closed. So it will not drain any water. Okay? And this would be another example. And to finish it off, let's just make a nice last visualization of the state from the watering. What do I mean? I want to know if the valves are open or not. And how can I do this? There is a virtual status, and this virtual status can be labeled or can be named valve backyard. And now I can say here in its properties, it's by default analog. So I can display with this here an analog value. I can validate it. I can say degree, or let's maybe do the same for the rainwater tank. So we can use it analog for 0 to 100%. But for the valve status, we want to use it digital, on or off. That's what the valve can be. So, sorry, we are here in the, this was the paid water and rainwater, but here are our two valves for backyard and front yard. So I connect this like this. Now I can say here, I give it a category, irrigation, for example. The room is garden by default when I add it to the room. And here I can give it as well a nice little icon. So maybe this valve actuator icon here. And then I can copy and paste it. Oops, copy and paste. Just rename it front yard. All right, like this, and save it to the mini server. Yes, there are changes on the mini server which I would like to take out, which is fine. And I mean, by the way, for this virtual status, you can see here the status text: 0 means off, 1 means on. You can also change it to 0 means open, 1 is closed, or the other way around. Closed is 1, no, closed is 0, 1 is open. That's what we need. So before I resave, I show you how it looks like. 0 is closed, 1 is open. So here you see now valve on, status on, and off if it's off. And if I save now again, then you will see it changes, because here the status text, closed and open. You can also make user-defined symbols, where you could say here the symbol value means something like, maybe there is an open or so. You could say on or off, then you don't see the text. Let's maybe save again like this, then you see the difference. Rebooting. By the way, if you get this message, external access denied, that's because, or external access blocked, that's because when the mini server reboots and you are locally connected, I'm in the Wi-Fi of the demo case now, then it tries to locally access it, and if it cannot, then it tries to externally do so. But of course, it's still rebooting. That's why this message comes up. So now you see here, the one I did not change. So here you see it's open, and the other one here means with the icon. Here this means closed, and the other one means opened. Okay, so this way you can display, and I've did it the wrong way. Value 0 means on and off, so I just did it the opposite way. So I have to turn it around. So 0 means closed, say disabled, and 1 means on. Okay? Or I keep it again as the other one. 0 means closed, 1 means open. I can also change the color, by the way. If I change it here to user-defined, I can say the open value should be blue, because then water is going, and red means closed. Also an option. So you are pretty free to define a lot of stuff here. Okay. Now for the water tank. the rainwater tank. We can copy and paste the input here, analog input, 0 to 100%, and we can use another virtual status, rainwater tank, and now we use it as an analog one, which is its default, and here we can say after the v.1 in brackets, we can say now percent filled, and v.1 means it's the value, and 0.1 means 1 digit after the comma. For a percentage of a rainwater tank, I probably just go with the full values, but for other situations, you probably want to have maybe 2 digits after the comma, then it would look like this. But here I go like this. Then we say it's the category, let's say also irrigation. Maybe we use an icon for the tank. There is probably none, so you could create your own icons, which I'll show you in a second. Here, edit icons, my category icons or room icons or whatever. You can make a new one here, and then you could say this is my nice rainwater tank. And of course, this is just a joke now, but you can also import PNG files with this size here. Okay, and then you can use your own icons if you need to. Okay, but for this time, I just go for the icon. I don't know. Doesn't matter. It does a little. Here, there's a water drop. Let's take this one. Okay, and now we save. And then you will see after rebooting, again, external access blocked. Again, because it tries to access it remotely, but once it's back up, then you see I'm connected. Here, garden rainwater tank is filled by 0, but I have on my demo case the potentiometer, which I can turn. It's the third one. So now you see my rainwater tank is filled 60%. Okay. I can also fake now, or no, not fake, but I can also turn up the first sensor, and then you will see the valve in the backyard is closed. So what I just did is I used the potentiometer in the demo case to control the first sensor here, which is the humidity of the backyard. And then you see I can now live demonstrate it. Actually, the blue color looks a little stupid, I have to say. I would go back to green then. You see? Okay. So, I hope this could give you a cool overview about what's possible with Loxone. There is a ton of different ways to reach the goal of what we just achieved. So that's the cool part. Everybody has its own ways to come to the end. And hopefully you got some new tricks from this video. Let me know if this is an interesting video format, if you would like to see more of these videos in the future. And I see you very soon in one of the next videos. All the best. Bye, guys.